So, chapter 10.7, we're going to talk about complex numbers. I hope you're about done with radicals because this section is going to wrap up our radicals for us. This section answers one question. And the question is the square root of -9 possible? Notice we're not going to talk about cube roots or fourth roots anymore. We're going to talk only about square roots. The question is the square root of -9 possible? What's the answer?
No. Yes.
You know what? Actually, you can't answer that right now because it's a trick question. You ready?
Yes.
It's a trick question. And the reason why it's a trick question is because if I ask you, is it possible in the real numbers, the answer is no. Because you can't think of a number times itself that gives you -9. Can you?
No.
If you can't, you're a smarter person than I am. No, you can't. There's nothing that exists. You take 3 times 3, you get 9. -3 times -3, you get 9. This isn't possible in the real numbers. However, I'm going to introduce to you today a new set of numbers. You're excited, right? Of course you are. What these things are called imaginary numbers. Now, I gotta clarify something. They're not called imaginary because they don't actually exist. They're called imaginary because they're like the opposite of real numbers. Do you get me? So real numbers are the group of numbers. Imaginary numbers are a different set of numbers. They're still there. In fact, if you don't know imaginary numbers, you're never going to be an engineer. A lot of engineering principles, the stuff that holds buildings up, is based on imaginary numbers. It's really interesting stuff. So we're going to talk today about imaginary numbers, and that's going to lead us into complex numbers. Here's a whole definition of an imaginary number. What we're going to be dealing with, there's only one thing we got to fix here. You see, the square root of -9 isn't possible because there's a negative inside of it. The 9's just fine, right? You can find the square root of 9. What we can't do is find the square root of the negative. There's really only one more thing we have to define in order to deal with this problem. And what that is the square root of -1. That's the only thing we have to fix. I know it's surprising me, like, wait a second. There's a whole other lot of square roots besides -1. Well, we're going to talk about those in just a bit. Right now, we just have to find one thing. It's a square root of -1, and we're going to define that as a number. As the number, this will seem weird, all right? We're defining this as the number I. You might think, wait a second, Mr. Leonard, I know I failed English, but I'm pretty sure I is a letter. Pretty sure that I is a letter. Here's what I need to distinguish for you. I is the square root of -1. I is not a variable. You can't plug anything in for I. It doesn't have a changing value. How much is I? Don't say -1. It's not -1. How much is I? The square root of -1. If you say -1, you got it wrong. How much is I? Everybody, how much is I? Good. It's a square root of -1. Every time you see this, it means this. Every time you see this, it means this. These things are interchangeable. They are the same exact value. The square root of -1 is I. Now, if you plug in the square root of -1 in your calculator, you know what's going to give you? Error. You're breaking me. Stop hurting me. Okay, yeah, of course, it's not going to work because your calculator can't distinguish that. Your calculator doesn't know what I means unless you have a real fancy calculator. It's not going to do that for you. You have to know that the square root of -1 is I. So the two things we need to memorize for this section. Firstly, I equals the square root of -1. The next one is just as important. Hey, this is an equation, right? Say yes.
Yes.
And you know that with an equation, if I do something to both sides, it's still equal. What would happen if I take both sides to the second power? So for instance, if I square this side and square this side, this side becomes I squared. Follow? If you square a square root, what happens? So how much is I squared? -1. That's why I can't ask you, how much is I? And you tell me -1. How much is I? It's not -1 because I squared is -1. You can't have the same thing, right? You go, I is -1 and I squared is -1. Well, something's going on in your head that's not quite right, all right? That's not happening. So what we need to know on this stuff is that I is the square root of -1, I squared is -1. This you must memorize. Now I know a lot of people walk in late, absolutely unacceptable by the way, but you need to memorize that and focus on this right now, okay? That's what you have to have down. This right here, this I, that's called an imaginary number. What this lets us do is lets us write any square root of a negative as something that's meaningful. This lets us rewrite square roots of negative numbers.
So it only works for square roots?
Well, you don't need it for cube roots.
Sure.
Fourth roots you can break down into square roots. So yeah, it only works for square roots. This lets us rewrite the square roots of negative numbers. Would you like to find out how it's done?
Yes.
You're like, no. Forget about it. Done. Let's go home. Let's look at the square root of -9, all right? All right. Is this possible? Well, that's a trick question. If I say, is it possible in the real numbers, you say no. That's why we wrote no real solution. Remember all those times we wrote no real solution? Not just no solution? Because there's a solution. We're going to find it out using our complex or imaginary numbers. Complex numbers we'll deal with in just a bit. Okay, right now we're just in the imaginary zone. Here's what you need to do whenever you have, that was pretty quick, wasn't it? That's right. Done this one, this one. Okay, here's what you need to do whenever you get the square root of a negative number. What we're trying to do is we're trying to break off a -1. Watch what I'm going to do on this problem. Do you agree with me that the square root of -9 is the same thing as the square root of -1 times 9? True statement? Absolutely mathematically true. Now, according to the product rule, we should be able to separate those things, true? Should be able to separate them. True? True. True. That's true. Remember, we've done this before, right? Okay. Can you tell me how much is the square root of 9?
3.
Look what happened. As soon as we broke off the -1, this changes into a square root that I can deal with, can't you? No matter what number that is, as long as it's not negative, you can deal with that. You can simplify it, you can take the square root of it if it's a perfect square. In any case, that is a, how much? That's 3. Now the question is, do you remember what the square root of -1 is? It's on the board, but do you remember? Every time you see the square root of -1, you're going to write what? Do you have to write the square root of I?
No.
No, this is the definition. Square root of -1 is I. So this is that. This is 3. This is I. Now, we rarely write it I3. Right? That would be a freeway, like I5. Okay, we don't want to do that. We're going to write it backwards. It's kind of like a variable. It's not a variable. It's not a variable. I is the square root of -1. But we're going to write it 3I, because we're more familiar with that. So we're going to write 3I. That means, what's that mean? What's I again, everybody?
Square root of -1.
Square. Is it -1?
No, square root of -1.
Square root of -1. So is this equal to -3?
No.
Definitely not. This is square root of -1, which you don't even know how to do that, right? I mean, it's not something that we can quantify in a real number. I is I. I is the square root of -1. It's not something you can plug in a calculator and get something out of. You can't do it. It's not real. It's not a real number. Does it exist? Yes. Is it real? It's not in the real numbers. It is real. It's on the board.
Philosophy class.
It's not philosophy anymore.
I was like,
Okay, we're going to try a few more here. Really get the hang of this stuff. In every single case, what we're trying to do is break off a -1 because right now we have a negative inside of a square root. We know that a negative inside of a square root is not possible in the real numbers. So instead of the square root of -25, can you tell me what I'm going to write that as?
25 times -1.
Or we could do -1 times 25. Either one. Doesn't really matter. It is commutative after all. That's a true statement, isn't it? Now what the product rule says is that I can split this up as the square root of -1 times the square root of 25. And in doing so, I change that 25 from from a negative into a positive, something I can deal with. Well, what we also know is the square root of -1, that's something as well. It's something we've defined over here. It's a definition. It is what it is. So in our problem here, how much is the square root of -1, folks? Every time you see that, what are you going to put? And how much is the square root of 25? It's really our free way. We're not going to put I times 5. We're going to put 5i. This value you can represent as 5i. We break off the negative. Square root of -1 is I. Square root of anything else, well, we can deal with that as soon as we remove that negative. How about the square root of -3? Let's try that. Square root of -3. Well, let's try the same process here. If you have the square root of -3, the first thing you might want to do is break that up as -1 times 3. Are you noticing how I'm just breaking off that negative? That's all I'm doing. Not sure if you're with me on that. Just breaking off the negative. And then, of course, we do have to separate that. Square root of -1 times the square root of 3. So far, so good? Same exact steps as before. What's the square root of -1, ladies and gentlemen?
I.
Okay, so this is I. What's the square root of 3?
Can't simplify.
Okay, you can't simplify, you can't do anything with it. So what do?
Put it on the outside.
Just leave it. We're done. Can't do anything with that. Square root of 3 is the square root of 3. It's not like square root of 25 where you can actually simplify that. This one, square root of 3, it's already simplified. There's no perfect squares to divide that. It's I root 3. You're done. Now you're probably wondering, wait a second. Here the I came second, here the I came second, here the I is coming first. What's the deal? Well, just like with variables, when you did this, you probably wouldn't write square root of 3x. You know why? Because a lot of people, a lot of you, end up making your roots a little bit longer, and a little bit longer, and a little bit longer, and pretty soon it covers the whole entire problem. Have you noticed some of you doing that? I've noticed it, because I grade your homework. Sometimes it happens, and all of a sudden your x is included in your root, when it's not supposed to be. If we write the x out front, you'll never have a problem with that. Same thing's going to happen here. If you wrote your I in the back, some of you are going to cover that I and forget that it's not actually inside the root. Okay, you're rarely going to have an I inside of a root. Rarely happens. We write the I out front. I root 3 is appropriate. That way we don't confuse the I as being inside the radicand. It's part of the radicand. Do you understand why we do that? Here it's not a big deal. 5i, there's no radical to confuse that with. Here we have that. So we're going to write the I in front of our radicals. Let's do one more. I'll give you a few to do on your own. Let's try, oh my, negative square root of negative 50. There's one for you. Hey, first question. First question is this. Does a negative times a negative equal a positive in this case?
No.
That would be like multiplying a whole number inside your radical. That would be like saying 3 root 6 equals root 18. Can you do that? That's what you're doing here if you did that. Okay? Because that's -1, that's -50. That'd be like saying that, wouldn't it? You can't do that. So a negative times a negative, well, you're not talking about that in this case. You're talking about -1 times the square root of -50. Now let's stick with the same exact principles that we have over here. We'll have a negative square root, okay, negative square root of, what am I going to break up the 50 as?
25.
Okay, I could do that first, but what am I first breaking off?
-1.
That's true, right? Right?
Yep.
Take your time when you're first going through this. Right now you're just learning it. You probably never ever saw this before. So don't rush through it. I mean, there's no sense in doing that and getting wrong answers, right? Take your time when you're first learning this stuff. After a while, I promise you, by next week, it's going to come so easy to you, it's not going to be a problem. You'll be able to do a lot of this in your head. Right now, go slow. So, the negative stays. Let's split that up. Square root of -1 times the square root of 50. Notice how I haven't even dealt with that negative. It's actually going to be outside of our problem the entire time. We're not even going to do anything with it. You're going to see this. This, we just split it up like we've done in the previous problems. So far, so good? Okay. How much is that? This right. Well, I know this is a negative. How much is that? So the negative is here. This is an I. And the square root of 50. The square root of 50. Can you split up the square root of 50? What was it? 25. So we're going to get 5 root 2. Do you see the 5 root 2? Remember, this is square root of 25 times 2. That's where we're getting the 5 root 2. We have negative I times 5 root 2. Raise your hand if you can get down that far on your own. Yes, no? Are there any questions on that before I could continue? All right. We're going to write this just a little bit better. Remember here how our whole numbers come first? Our radicals come second? That's a negative, so what you can write this as is negative 5i root 2. Negative 5i root 2. Same principles. Whole number would come first, then an I, then a root. Weird, huh? Isn't that kind of cool stuff? You're dealing with things that are impossible in real numbers. That's kind of interesting. Never been able to do this before in your life, have you? And now we can deal with something. Would you like to try a couple on your own? Let's do the square root of -7 and negative square root of -18. So put those in, we'll call this I form. Put this in I form for me. Okay, so square root of -7. I'm hoping you did this. I'm hoping you split up -1 times 7. Did you all see that? So we're just splitting off -1. That's the only thing we can do because we've defined the square root of -1 as I. That's the only definition I gave you. That's it. So we'll have the square root of -1 times the square root of 7. Square root of 7, I can't simplify that at all. The square root of -1 equals how much?
I.
Your answer is I root 7. Raise your hand if you got I root 7. Good, all right. Now, next up. Next up. What are we doing here? So this doesn't change? Okay. What's inside of our radical?
-1
Times? Good. We're just splitting off the -1. We have to split off that -1 before we do anything in these problems. Please listen, anything. Over here, anything. If you have a negative, split it off first before you do anything. Okay? Because those operations we've dealt with don't really apply to the negative roots. Or you have to change those into reals before you deal with this stuff. Okay, so we know that this is going to be negative square root of -1 times square root of 18. We have to split off that square root of -1. The reason why is because we know everywhere we see the square root of -1, we're going to put I. So we have the negative, we have the I, and the square root of 18, I'm thinking that's going to be 3 root 2. Yeah, that's right, 3 root 2. So after everything, on your paper you should have a negative. Sure, negative was all the way down. Look at that. Negative didn't even affect our problem. 3, then an I, then a root 2. Would you raise your hand and feel comfortable doing at least the I form? All right. I'm expecting now to be able to do this I form every single time. Now, there are some operations we're going to have to do with these imaginary numbers. And the first one we're going to talk about is this multiplication of two roots. Remember, we're only dealing with square roots in this section. Okay, so we're dealing with these roots. Now, here's the thing. I want you to watch up on the board. Just watch with me for a second. If you try to use the product rule in reverse, what this would say is you'd have the square root of -2 times -7. True? You say, oh, what's a negative times negative? And you get square root of 14. All right, all right. Or, could you change those to I? Notice how this is going to be I root 2, and this is going to be I root 7. Are you following on that? This one is I root 2. Notice how whenever you see a negative inside that root, all it does is bring outside and you have an I. I mean, this is, you know, this is going to be negative I root 50, split down to 50, or break down to 50. This is going to be I root 7. This is going to be negative I root 18, split up to 18. So whenever you see the negative inside that root, that is simply an I. Are you okay on getting from here to here? You sure? I can show you the steps if you need to, but all I'd be doing is breaking off -1, square root of -1 is I, then we have a 2. Times, this will be I root 7. Do you agree? Now I need you to understand what this actually means. This means I times root 2 times I times root 7. Do you follow? Multiplication is called associative because you can move around those little factors and it's still the same thing. For instance, 3 times 2 times 5 is the same thing as 2 times 3 times 5. I can reverse those, right? Yes?
Yes.
Okay. What that means is that this really could be written as I times root 2 times root 7. Do you agree with that?
Yep.
That's true. It's a true statement. How much is I times I? I squared times root 2 times root 7. Okay, this is the weird part. Watch on the board. Root 2 times root 7, you know for a fact that you can put those things together, right? This is square root, positive numbers inside. You know this is going to be the square root of 14, right? How much is I squared? Yeah, there's two things that be tattooed on your brain. It's going to be painful. Okay, tattooed. The first one is that the square root of -1 equals I. You've been doing fantastic with that. That's got to be memorized. The second one is just as important. How much is I squared? You have to memorize that. That means every time you see this, you're going to write that. Every time you see this, you're going to write that. You with me? Every time. So whenever you see I, how much is I squared?
-1.
How much is -1 times root?
Negative root 14.
Whoa! Wait a second. Which one's right? Which one's right? The only thing we failed on this one, the only thing that we succeeded on this one was the product rule. You see, when I defined the product rule, it was not defined for imaginary numbers. It was defined for real numbers. So what this means is that in order to really use all the stuff we've been doing, I hope you're listening here, in order to use all the stuff you've just learned in every previous chapter, you have to change it into real parts. This is now a real part. That's now a real part. I mean, a real number in the real system, okay? Here, this wasn't. I didn't change those to reals yet. This operation is not defined for imaginary numbers for the product rule. You can't just multiply them like you would a real. They're not reals. It's not defined. So this part failed us. That's actually not true. You can't do it. You have to change to I form first and then do the math. So is it root 14 or negative root? It's negative root 14. We know that this is all true. We know that's all true. This is the true part. Did you see the point? You got to change the I form first. And this is absolutely crucial for you to identify every single time you see it. You cannot mess that up. Let's try a few more together. We'll do 3 more together. I'll give you a couple on your own. Then we'll finally get into complex numbers and look at what those things do. That'll be a fun part. That's good. I think you will really like the I promise you'll really like the complex numbers. I just lied. Some of you might not, but I like them.
Think calculators do?
I'll like them enough for all of us. All right?
Thank you.
Okay, good. We're good. Okay, first thing is to multiply these and get positive 25, or first thing is to change the I form. Which one? Every time you see a negative square root, you are going to change the I form first. That's what I've been saying this whole time. So the square, can you identify how much the square root of negative 1 is? How much is this over here? So I know that's an I. Okay, very good. Now the square root of negative 25, how much is the square root of negative 25?
5i.
This is going to give you the I. This is going to give you the 5. You should get 5i out of that. Not the square root of 5, but 5i. Do you see why? We've actually done this problem before. Look back at your notes. We did the square root of negative 25. This is 5i. 5i times I. How much is 5i times I?
5i squared.
Okay, so 5i squared. How much is I squared, everybody?
Negative 1.
Good. I could actually write it 5 times negative 1 if you'd like. I squared is negative 1. That's going to be negative 5. This answer is negative 5. We had to write negative 5 in there.
So it's just converting imaginary numbers into real ones.
And we're converting negative square roots into imaginary numbers. They are representing the same thing. We're just writing it a little different. This still is a square root, right? And that still is a square root. This is the square root of negative 1. This is the square root of negative 1. All those principles of roots that we've dealt with work. They are roots. You're just writing them as i's. First thing, tell me. I form. Square root of 27 times, can you tell me how much this is in I form? What would you write that as? A square root of negative 3. Good, the negative gives you the I. The root 3 stays the same as root 3, you get I root 3. We've actually done this one in class as well today. So far, so good? Okay. All right. What now?
Simplify 27 to 93.
You could. There's actually 2 ways to do this. First way, simplify this one. Multiply root 3 times root 3 and get 3. Second way, multiply these 2 roots. Notice how they're both real roots now and you have a multiplication here, right? What's root 27 times root 3? That's something I can deal with. That's root 81. How much is the square root of 81? Get 9 out of this. This is going to be 9i. Either way you do it. You could do 3 root 3 times I root 3. You know a root times itself gives you the radicand. Do you remember that? Mm-hmm. This is 3 times this gives you 3 times I, or 9i. Or you could do square root of 81 times I, 9i. Either way, you get 9i out of that. Do you see both ways on that? Mm-hmm. Both ways there. Square root of negative 8 over 2 And you know the first thing you're going to do is change it to I form. Right now I want you to change the numerator into I form for me. What is that as I form?
2y square root of 2.
You're definitely going to get I, right? So you know that's going to be I root 8. Y'all get I root 8 at some point. Now, can you simplify the root 8? Don't forget that you can simplify these. Now they're just normal square roots after you take the I out. So if we simplify the square root of 8, this is going to be 4 times 2. That's 2I root 2. How many people got 2I root 2? Left side? Yes, okay. So remember, this is square root of 4 times 2. You have the I. This gives you a 2. 2I root 2 over root 2. What happens with this problem?
Cancel out the root 2's and we'll get 2 on the right side.
It's all being multiplied, right? So any factors you have that are being multiplied, cross them out. You've got a root 2 and root 2. Gone. That's awesome. What if you didn't do that? What if you had I root 8 over root 2? How would you do it? Well, you now have a square root over square root, don't you? You could write this as I root 8 over 2. Now you can combine them. Now you can, because you don't have the negative in there. You have I root 4, or you'd have 2I. In either case, you're going to get 2I. So are there multiple ways to do these problems? Absolutely. Both of them are valid. Neither one is better than the other. Okay, you can do it either way that you want to. I really don't care, as long as you're changing to I form first. How many people feel okay about changing to I form first? Good. I'm going to have you do, let's see, maybe 2 on your own. Then I'll talk about complex numbers.
There you go.
So we change to I form first. Oh my, don't multiply these together and get like a square root of positive 30. That'd be a big no-no. That doesn't work for those imaginary numbers. All because I squared is going to give you the negative 1. So change it to I form first, then look what happens. Looks like we're about done. I'll give you a few more seconds here to wrap up the number 2 if you haven't done that. Okay, so square root of negative 5 times square root of negative 6, we can't multiply those the way they are. The first thing you do whenever you see the square root of a negative number, change it to I form. That way you're safe in every case. You're going to notice a couple things, especially on this problem. If you were to put those together as one root, which you technically shouldn't do, you would get the square root of negative 9. That's going to give you 3i. That's probably going to be your answer at the very end of this thing anyway. Did you get that as well? Okay, so sometimes it looks like it can work. It does actually here, because you only have that one negative, and you're not going to cross out that negative. You're not going to eliminate the I. Here you can. So in both cases, though, it is appropriate to change this to an I first. I root 5 times I root 6. Are you okay that I'm going directly to here to my I's? Is that all right with you?
Yeah.
Okay. It's pretty quick to catch on to that, isn't it? Not too bad. Then we notice that we have I times and I times. So we've got this I squared. Notice where we're getting the I squared from? Root 30. Did you make it down to I squared root 30? We reassociate the I's. I times I gives you I squared, root 5 times root 6. We can do that now because they're now real parts. We get, how much?
Negative root 3.
That's negative 1. Negative 1 times root 30 is negative root 30. That's it. That's what you do. Cool. Next up, we are going to change I form first. That's what you really should do every single time you see this. So we get here from the square root of negative 27,
3I root
I root 27 over root 3.
3.
You've got two choices. You can choose to simplify the square root of 27, or you can put those roots together. Either way you want to do that, it doesn't really matter. You can do 3 root 3, or 3I root 3, over root 3 and cross out the root 3's. Or, if you prefer, you can combine these things, get the square root of 9, because 27 divided by 3 gives you 9. In either case, you're going to get 3I out of this problem. Are you with me? I'll show you this one, because for some reason, I feel like doing this today. That's just who I am this week.
Late reading.
Not this morning. Not this weekend. I'm DJing, emceeing this weekend. I'll be on a microphone all weekend. Okay, how many will feel okay changing I form and simplifying some of these roots? Yes, no? Yeah? No? All right. Oh, I almost flipped you off there. Complex numbers. We've been dealing with imaginary numbers. All these i's are called imaginary numbers. They're just a little part of a different group of numbers. It's called the complex numbers. See, here's the thing. What we're going to do now is pair up a real number with an imaginary number, and that creates the set of complex numbers. Now, you probably have no idea how big the set of complex numbers is. We'll talk about it in just a second. A complex number is of this form. A plus bi. A plus bi. A is called the real part. It'll be a real number, like 3, negative 2, the square root of 5. Something without an I in it. So A is called our real part. Bi, well, the I is imaginary. So the Bi, that's our imaginary part. So we're going to have something like positive plus or minus here, like 3i, or negative 4i, or the square root of 7i, something like that. Or I root 7 is how we'll really write it. This is the imaginary part. If we pair them up like this, we get a complex number. Now, I've got to tell you that you probably think the real numbers are a huge set of numbers, right? I hope you do, because they are. They're infinite. I mean, every number you've ever thought of before this section was a real number, right? 1/4, real number. Square root of 8, real number. 34, real number. All the negatives, real number. Pi is a real number. Every terminating, non-terminating, repeating, non-repeating decimal is a real number. Everything. Now, what we're doing is we're pairing up a real part, a real number, with an imaginary number. Here's what this means. Try to grasp this. For every real number you can imagine, everything, I could add on an infinite number of imaginary parts. Give me a real number. Any real number you can think of.
7.
7, great. I can have 7 plus 2i. 7 plus 3i. 7 minus 4i. 7 minus the square root of 2i. 7 minus 8i. 7 minus a whole nother set of numbers that's infinite. Anything you can think of. So for every real number, you have another infinite set of imaginary numbers that you can pair up with it. Do you follow how big that is?
Huge.
Now give me another number, negative 2. You can do the same thing. They're massive. In fact, every real number you've thought of is encompassed in is encompassed in complex numbers. Complex numbers are a much larger set of numbers. Here's how I can show you this. All numbers are complex. If you take all numbers are automatically complex numbers. Let's take that number that someone said, 7. If you give me the number 7, now that's clearly a real number, right? Right?
Yes.
Now check it out. Can I write it of this form? Absolutely. My real part is 7. My complex part is 0 i's. I don't have any i's. That's automatically a complex number. Kind of neat, right? Do you see how that's possible? 7 plus 0 i. It's complex. Doesn't say anything about what b has to be. This is automatically a complex number. Or if you give me an imaginary number, let's say, what's on the board? 3i. If I take 3i, what's my, okay, watch carefully, listen a bit. Were you okay that the real part here was 7, and the imaginary part, there wasn't one, so I put 0i? Be careful here. What's my real part?
0.
0. It's not 3. This is part of the imaginary part. Are you with me? So the real part would be 0 plus imaginary part's 3i. Every imaginary number is automatically a complex number. That means that every number you've ever had in your life, every number that exists, is automatically, without a doubt, a complex number. It's the biggest set of numbers we have. So far, so good?
So by calling them imaginary numbers, it's not that they're fake numbers, they're just not
Real.
able to be logically expressed.
No, it's logical. What? Very logical. It's just they're not real. They're not in the real number system. So we can't call them real numbers anymore.
Because real is a group, not like talking about reality.
Right. Real is a group of numbers. Imaginary is another group of numbers. Put them together, you get complex numbers. That's what you got. Let's talk about how to add and subtract these. Now, you probably might think, oh my goodness, these are complex numbers. Adding and subtracting them is going to be complex. No, not complex. I'll give you an example, for instance. Let's do 5 plus 2i plus 4 minus 3i. The only reason these parentheses are even there, ladies and gentlemen, is to show you that I have one complex number plus another complex number. Can you guys see the complex numbers? I know it's weird to you because this is new. That's one number. That's one number. You with me? Tell me what the real part is here.
5.
What's the imaginary part
2
here?
Negative 3.
Negative 3 goes with the sign. What's the imaginary part here?
2.
Real part here.
4.
Check it out. Do you remember how, you remember how to combine like terms? How you combine like terms is you get rid of parentheses first, and then you combine like terms. Notice that we do have addition. I need to be very clear on this with you. Would you distribute this problem?
No.
Is it multiplication?
No.
Am I going to go 5 times 4? Am I going to do that?
No.
No, don't do that. I'm going to give you a problem just like this on the test. It is the easiest 10 points you're ever going to get, unless you distribute, and you get 0 points. Okay, know what addition means. Addition means, well, if there's nothing to distribute out front, I get to just drop the parentheses. How about this? Do the signs change inside of this one?
No.
So what this means is just plus 4 minus 3i. True? Do you have some like parts? Do you have real parts?
Yes.
Do you have imaginary parts? Add them. Combine them. Combine them like you would like terms. I know that 5 and 4, those are like parts. How much does that make? I know that positive 2i and minus 3i, those are like parts. How much is positive 2i minus 3i? Minus I. Can you combine these things? No. This is very much like terms. I know that I is not a variable. In fact, how much is I? You should all know this.
-1.
No.
Square root of -1.
Yes, square root of -1. So what you have here is a number minus a square root, right? What you have here is a square root and a square root. They're like roots, as a matter of fact. This would be 2 root -1. This would be 3 root -1. That's why you can combine them. They're not variables. You can't plug anything in for I, but you can combine them as if they kind of were, because we did that with our roots as well. That's your answer. Kind of nice? Kind of nice. Let's try some subtraction. I'll give you a few to do on your own. Probably call it a day after that. Six I minus 2 minus I. All right, well, let's talk about this for a bit. Firstly, recognize we do have two complex numbers. Everything's a complex number. What's the real part here?
0.
0. The real part's not 6. This is associated with the I. The real part's 0. How much is the imaginary part? Good. What's the real part here? Imaginary part. I or negative I? Negative I. Goes with the sign. Can you tell me what's going to happen here?
Distribute negative among.
Just like combining like terms. You get the 6i, sure. But what are you going to get when I distribute my negative?
Negative 2 plus I.
Wait. Why plus I?
Negative.
Good. If you forget to distribute that, are you going to get the right answer?
No.
So this, when I go, that's going to be a plus I. Now I know a lot of you that you like to do this. You like to see these like parts here. You like to combine them. How much is that going to be? Is it going to be 6i squared, or 7i, or 7i squared?
7i.
Squared?
7i by itself.
Are you multiplying or adding?
Add.
Just like terms. 6x plus 1x would give you 7x. True?
Yes.
6i, 1i gives you 7i. Now, we do have to write these in the appropriate order. So, is it going to be 7i first or last?
Last.
What comes first then?
Real number.
So, identify your real parts first. We have negative 2. This is 6i plus 1i, that's plus 7i. Negative 2 plus 7i. Okay, last one we'll do together, then I'll give you 3 to do on your own. We'll go over them very briefly, and then we'll be done with our day. Oh, what are you going to do here?
Distribute the negative to the second.
Notice our two complex numbers. We have negative 2 is our real part, negative 4i is our imaginary. Negative 3 is our real part, positive 1i is our imaginary part. Are the signs on your first complex number going to change, ladies and
No.
gentlemen?
Yeah.
Someone on the right side of the room for me, can you tell me what I should write here, please? Good, plus 3. Not two signs. You know a negative and a negative is a positive. And then what? Good. Follow me? Make sure you distribute those correctly. Make sure you get the appropriate signs there. Because now all you've got to do is combine some like parts. We do our real parts first. What's our real part going to be, everyone? Okay? And then I have a minus 4i and a minus I. You're basically combining like parts here. You're going to get what? Can't go any further than that. That's it. Okay, try a couple on your own. Let's do 3 minus 5i plus negative 4 plus I. And that one. Were you guys okay on this example? Do you need another one like that, or are you all right with that one? Very, very similar to these problems. Go ahead and do those. I'll give you about 30 seconds and we'll wrap it up. Hey, do any signs change on the first expression?
No.
Do I need to distribute and FOIL this?
No.
So 3 minus 5i plus, okay,
Negatives.
negative 4. What I could do here is just write minus 4. Do you see that? I could just write minus 4 and then plus I. So far so good? This is going to give you negative 1 minus 4i. Raise your hand if you got that. Good. Next up, we do have to distribute the negative. Not FOIL, but distribute the negative. you'll get negative 5 minus 2i. You'll get plus 8 plus 4i. Did you get plus 8 and plus 4i? Good. Follow that sign. You got to have that. Our real parts give us 3. Our imaginary parts give us minus 2i. And now we can add and subtract. I'm sorry, plus. Thank you. Plus 2i. We can add and subtract those complex numbers. Do you feel okay about what we talked about today?
Yes, sure.
Next time on Monday, we'll talk about how to multiply and divide them. It'll go very fast. Then we'll start chapter 11 on Monday. Well, good morning. If you remember from last time, what we're doing here is we're doing a few things with the square root of negative numbers. We realized from last time that the square root of negative isn't a real number, but is an imaginary number. It's a different class of numbers. And when we pair that together with a real number, we get something called a complex number. The whole idea is, can you put these roots into I form, and then can you do some operations with them? We've practiced I form a lot. We've also done the addition, subtraction. We're going to get to multiplication, division in just a little while. First, let's practice doing this problem. What I'd like you to do on this is make sure you can put that in I form before you do anything with it. So right now, take about 5 seconds. It's not hard. It doesn't take a long time. Put this in I form for me. So I form means you're getting rid of a square root of a negative number somehow. So let's take a look at it. Do we need to do anything with the 4?
No.
Okay, so I know this is just going to be 4, and this minus is still going to be a minus. All I'm asking you to do is convert that root somehow. Now, what is the square root of negative 25? Is it a real number or an imaginary number?
Imaginary number.
Definitely, because it has that negative inside that root. What does that negative create?
I.
Somehow it's going to have an I. And if you remember from last time, I will show this to you one time because we've done this quite a bit. You can refresh your memory on that video. But what we would do is with the square root of negative 25, we break that off and do negative 1 times 25. We'd split up the root, and we would have I times 5. We determined that, and we defined that the square root of negative 1 is actually I. And that's what we're using this as. So instead of I5, we'll have 5I, and that is called I form. Do you remember that from last time, ladies and gentlemen? Okay, so here, instead of 4 minus square root of negative 25, we're going to have 4 minus what?
5I.
Minus the negative 3 I can't do anything with. The plus I can't do anything with, but that square root of negative 4, how much is that?
2I.
Good, we take the square root of 4, square root of a negative, that's negative 1. That's going to be our I, so we get 2I. Notice how I haven't really done any other math besides changing that into I form. That's the whole idea. Make sure you get I form first, then go ahead and look at the problem that you have. So I form, very important, we're going to do that first. Next up, let's look at what we're actually doing. Are we adding, subtracting, multiplying, or dividing?
Subtracting.
And in fact, we have complex numbers now. Did you guys see the complex numbers?
Yep.
What's the real part of this complex number right here?
Negative 3 and 3.
Right side of the room, what's the imaginary part of this complex number over here? It goes with the sign. Okay, good. Now, if we're subtracting, do I need to FOIL this? Do I need to distribute that? No, really, all I need to do is make sure this negative switches these signs, because we're subtracting them. Just like combining like terms, we remember how to get those parentheses out of there. So we'll have 4 minus 5I. We'll have, what's next? Plus or minus? That's okay. And then what?
Minus 2.
And after that, essentially what we're doing is combining like parts. Very similar to combining like terms. Now, remember that, is I a variable? Is I a variable?
No.
How much is I?
Negative 1.
No, I is not negative 1. Square root of negative 1. Yeah, I can't have you say I is negative 1, because I squared is negative 1. You can't have the same thing for both of them. So I is not negative 1, but it's the square root of negative 1. So what we're really doing here is we're combining a couple of like roots. These are the square root of negative 1. That's why we can combine them just like a like term. And then our numbers are always like terms. So we'll combine our 4 and our 3. That'll give us 7. We'll combine minus 5I, minus 2I, and get minus 7I. That's as far as we can go. The real part's 7, the imaginary part's negative 7I. We're done. How many will feel okay with the adding and subtracting? Good. Now for the rest of our time in this section, we're going to talk about how to multiply and how to divide. We'll talk about multiplication first. You know there's really only one thing that you need to know in order to multiply these complex numbers? Really, that's it. Just this right here. You need to know and have down in your head at all times how much I squared is equal to. How much is I squared equal to? That's it. If you remember that, and if you remember that every single time you see I squared, you're going to put what?
-1.
If you remember that, then you can be finding multiplication. You see, here's what we're going to do. When we multiply, oh, by the way, if this is true, should you ever have any I to greater than the first power? Should you ever have an I cubed or an I fourth or an I to the... No. Because if you know this, you can always simplify them. And we'll talk about that in just a bit. But we're going to be multiplying, and it's going to look very, very similar to some multiplication that you've seen before. So let's say I gave you negative 5i times 3i. Well, hey, if you can do this problem, which you've done before many times, right? You can do this problem. Because it's the same exact idea. You're multiplying two things. You're multiplying negative 5i times 3i. You're going to be multiplying the numbers together. You're going to be multiplying the i's together, just like you multiply the numbers together here and the x's together. Now, while this isn't a variable, it is a root. And we know that those roots get multiplied just like any other numbers do. What would you get out of this problem here?
Negative 15x
What do we, x or x squared?
squared.
Where's the x squared coming from?
Two x's and multiply.
Okay, so you need to know that combining i's by addition or subtraction is different than combining i's by multiplication, right? Just like combining roots with addition was different than combining roots with multiplication. We realized that. That was a big part for us because some people were still putting roots where you didn't need them or not having roots where you did need them. So on this case, we're doing an I and an I, yet it's still only giving us an I because we're adding and subtracting. Here we're going to do an I and an I, but it's not just going to give us an I, it's going to give us an x squared. Oh, sorry, not x squared, no, we got that. We're going to get an I squared because we're multiplying just like we are right here. So where we got negative 15x squared, we'll get negative 15 I squared. Do you see where the I squared is coming from?
Yeah.
Do you see why we have it here, but why we don't have it here? Do you?
This is math. Put together like terms and all this.
Sure, we're combining like terms here. We're multiplying over there. Different story. Addition, subtraction, multiplication. Raise your hand if you feel okay with it so far. Okay, good. Now, we just finished talking about something. Just finished. Should you ever have an I squared on your paper?
No.
Let me tell you something. If you finish with an I squared on your paper, you've either done something wrong or you're not done. All right? So if you finish the problem with I squared, you can't have that. Why? How much is I squared?
-1.
So instead of having negative 15I squared, I know it's negative 15 times negative 1. Can I complete this problem?
Yep.
It's just negative 15 times negative 1.
15.
So interestingly, we don't even get an I out of that. Look at that. We've got a negative 5I times a 3I. We get positive 15. It's weird, right? Things happen with roots. These are roots. These are roots here. And what's happening is you're multiplying a root times itself. Notice that? A square root times itself. What's a square root times itself do? Gets rid of the square root. That's why we do this. That's why this happens. We're going to use this idea in division in just a little while. Do you feel okay with our example up here, why we get positive 15 out of that? Yes or no?
Yes.
You sure? If not, ask some questions. We get time. Get nothing but time. All right. Well, let's continue. Let's look at a few more. But as long as you do get this idea that we're not supposed to have an I squared at the end of a problem, that's actually negative 1, and we're multiplying very similar to like we've multiplied before in this class, then you're going to be okay. Let's build this up just a little bit, try a few more examples, and if you have questions, please let me know. All right. What do you say, folks? What do you think? What are we going to do on that problem?
Distribute.
Just like we would have done if these were variables. Now, these are not variables, they are roots. But just like you do with variables, you're going to distribute those. We've got a parentheses, we've got a term outside, a factor outside being multiplied. We know we can get rid of those parentheses by multiplication. So, can you tell me? Let's go left side of the room. Left side of the room, what's the first thing I'm going to get out here, please? Good. Perfect. Negative 18i, do you see where that's coming from? Just like as if that'd be a variable. And we're also going to multiply this in here. Am I going to get plus or minus? What do you think? Yeah, don't forget how to distribute. We all know how to do that. Plus, oh, let's see. What are we going to get? Plus what?
I squared.
Firstly, do you see where the plus is coming from?
Mm-hmm.
Okay.
Negative.
So plus, we're going to have 6. And are we going to have I or I squared? What do you think?
Squared.
I squared.
Are you done?
No.
Can you combine these?
No.
Can you combine? Are they like radicals?
No.
No.
This is actually a square of a radical. That's going to go away. That's why we can't have an I squared. You're going to simplify that. How much is I squared, folks?
Negative 1.
Okay. Now, go slowly on these things. I know that they are going to be easy for you. They're going to get easy. Are they already easy for you?
Yep.
Mhm.
They're going to get easier for you because you're going to get used to it. However, when you speed through them and you try to think of all those negatives in your head, sometimes you get a little lost. All right? So I don't want you to go directly from here to your final answer, because this negative times a negative, then you're going to have another negative in there that can really get wrapped up in your head and make some mistakes with that. So show me the steps on that. It doesn't take a long time, right? Maybe 2 steps, maybe 2 or 3 if you have a really rough problem. But show the work. Make sure that you really think about what's going on. Are you with me? Yeah, otherwise, something bad's going to happen. So we distribute, we get negative 18i, we get positive, negative, positive 6i squared. Can I change this I? No, that's a square root of negative 1. I can't change that. Can I change this I squared?
Yep.
So do that. I know I have negative 18i plus 6. And write this out. Write it out before you change anything about it. Leave the plus, leave the 6. Just change that part. How much is this part right there?
Negative 1.
Good. Now go ahead and do the math. Now that you've translated the I squared to the negative 1, now multiply, and that's where we can change our signs here. Of course, we're going to leave it negative 18i. That's not going to change. But am I going to get a plus or a minus 6 after I do that math? Would you raise your hand and feel comfortable getting down to this far? Good deal. Now, there's one problem with this. This is a complex number. However, it's written a little bit backwards. You guys see what I'm talking about?
Yeah.
We typically like to write the real part first. So if we do that, we're just going to move these pieces around with their signs. We'll have negative 6 minus 18i. That's the appropriate way to write a complex number. Let's go ahead, we'll do a few more examples. I'll give you a couple to do on your own. Move on to some division. Look at how we do that. You know what's nice about these problems is even though we're working with like I squared and we're changing those things, at least they look familiar, don't they? Look like things we've done since literally the first day of class. We've done things like this. How are you going to do this problem? You're going to distribute. In this case, do we FOIL?
Yes.
So notice how this problem is a different problem than if we would have a plus or a minus between them. If I have a plus or a minus between it, am I going to distribute it? No, definitely not. No, because then I'd be adding or subtracting two complex numbers. But here, since that is multiplication, that does clue me into let's distribute it. Let's go ahead and let's do that together. If I distribute everybody, what's the first thing I'm going to get?
18
And then what am I going to get?
plus 3i.
Great, I like the plus 3i. I'll do that. After that, I've done the 3 times the 6 and the I. What's next, folks?
Minus 24 squared.
Minus 24i.
I
Okay.
squared.
I swear, where's the, where's? I don't
Oh,
see
sorry,
one. Okay.
wrong.
And then lastly, we're going to do this one. We're going to get how much?
Negative 4i squared.
4i squared.
That's the I squared. Do you guys see where the I squared's coming from?
Yeah.
You can't afford to have an I squared where you don't need one. You can't afford to forget an I squared where you do need one, because that's going to change your problem. You see, look at this. Look at the board with me. I know you're working on your own because you guys get this. That's great. I'll give you some in a bit. But if you do this, notice how now this all becomes like radicals. Do you see it? But if you do this, these two are ultimately going to become like terms. Do you see it? So that's the difference. You'd be adding or combining the wrong thing.
So there's never 3 different types inside a complex.
No, inside a complex number, you have 2 choices. You have something with I or you have a number. That's what I'm saying here. You can't ever end with an I squared. There's no such thing as having an I squared at the end of your problem. You can always simplify them. Always. So you'll either have numbers or I's. You never have an I squared, I cubed, I to the 4th. Never. It doesn't happen. Are you still with me? Now, before we go and combine anything, we're going to change any I squares that we see. Of course, I have the 18. That's good to go. And I've got the plus 3i. There's nothing I can do with that. And the minus 24i, again, there's nothing there. Well, there's something there, but I can't change it. And then over here, though, that I squared, that's going to be something I can change. I know I have a minus 4. I'm not going to change it yet. I really want to think about what I squared does. I want you to realize that. This isn't just changing signs. You're changing I squared to a negative 1. Ultimately, that is going to change your signs, but I want you to show that work. That clues me in that you understand what I squared actually means. You still okay?
Yep.
Okay. So the 18, no problem. Plus 3i, okay. Minus 24i. Am I going to have minus 4 or plus 4 after that?
Plus 4.
Sure. That's what that I squared is doing. What next? Let's do it. We should have only numbers and i's. See a couple numbers, 8 is 22. We'll write our real part first. I've got a 3i, a minus 24i. That's going to give me how much? I?
Yep.
I. Done. That's it. We have a real part, the imaginary part. That's our complex number. Hey, tell me something. What are you going to do with this problem when I give you one like that on a test? If I give you one like that on a
Write
test?
it out.
So you're not just going to square this one and square that one?
No.
We can't just do 1 plus 4i squared or minus 4i squared?
No.
Now, unfortunately, if we did that, we'd be missing some middle terms here. So when we get something squared, of course, when we're multiplying, we do this with distribution when we first started that. We are going to write it out. You can say, oh yeah, I know that this means 1 minus 2i times 1 minus 2i. And from there, sure, we can FOIL it. Why don't you go ahead and FOIL this out for me and see what you get? All right, so if we distribute, we're going to get the 1 times 1. I know that gives me 1. Then I'm going to get the 1 times minus 2i. That's going to give me minus, well, 2i. But then I have that same thing again. I have minus 2i or negative 2i, which you can consider it as, times 1. That's another minus 2i. But lastly, I have minus 2i times minus 2i, or negative 2i times negative 2i. That negative, negative, that's going to create a positive for us. So plus, and I will get 4i squared. How many people have that on the paper? Good, that's just our distribution, right? I mean, we need to at least know that part of it. Now, the important part for us, the extension part of this is really old stuff, right? I mean, we really need to know this in order to even be in the class. After this, the part we're extending the concept is just I squared. That's really it. Can you do something with the I squared? So here it's the 1 minus 2i plus 4. Just change the I squared to that negative 1. We know that's a definition for us. Every time we see I squared, it means negative 1. What that does is simply change that sign, really. 1 minus 2i, and then minus 4. Lastly, if we put our like parts together, we've got 1 minus 4, that's making a negative 3. We've got a minus 2i and a minus 2i. How much does that give us? Are you done? Negative 3 minus 4i. Do you feel okay with doing this so far? All right, let's look at the next problem. Do you remember the relationship between this type of a complex number or this type of a complex number? Do you remember this relationship? We talked about it before. However, I was using roots at that time. I was using those roots. Now, in fact, do we actually have any roots up here?
Yep.
We do. How much is I?
Negative square root of negative 1.
It's the what now?
Square root of negative 1.
The square root. So that's a square root, right?
Yep.
And that is also a square root. Do you remember the relationship between this and this?
It's going to cross out the two middle terms.
Yes, I know, but what was that called? I know the middle terms probably are going to cancel out here, right? Because I have different signs here and I have the same.
Conjugate.
Some people said difference of squares. That's what I would give at the very end of this problem. But say it again.
Conjugate.
Conjugate. Remember that? Conjugate? It's conjugate. It was a conjugate that we had. We have the same exact terms. It's just the sign in the middle is different. What that did with our roots, was basically eliminate the square roots out of our problem. Because we knew this. A number times a number is going to give us a number. We knew a root times a root would eliminate the root, give us the radicand. That was for the square roots. But those middle terms will be off by a sign. That allows you to cancel them out, cross those things out, because when you add them together, they make that 0. Do you remember doing that? Now let's see if it works here. It should, because we still have square roots. We're just writing them as i's. Let's see if it works. So distributing, can you all tell me what's the first thing I'm going to get?
36.
Okay, keep going. What's the next thing I'm going to get?
Minus
Negative
30.
30.
Not 3. Minus 30i. Yeah, that's right. Minus 30. Do you see where we're getting the minus from? Plus 30i. Great, okay.
Minus 25.
Great. Positive times a negative. That's a negative. All right. Minus 25i.
Squared.
Don't forget the I squared. That's going to change your problem, right? Don't forget the I squared. Do you see anything interesting that's going to happen?
Yeah, the two middle terms cross out.
Yeah, they do. I've got a minus 30i, and I've got a plus 30i. That's what happened with those conjugates before. That's what's going to happen with these conjugates now. We do have 36 minus, from our minus 25i squared, I can write that minus 25, I squared is negative 1. You see where we're getting this minus from and the negative 1 from. Are we going to add or subtract 25 to 36?
Add.
Yeah, this really means that. And that really means,
61.
wow, that's weird. Look at that. We started with this. We ended with a whole number. Isn't that kind of crazy? We eliminated the roots. I's are gone because I squared is negative 1. If you don't remember that, you're going to end up at this part, right? You're going to have some sort of negative I squared up there. It's going to look weird. It's not going to be the number. You would still think in your head you have a root when in fact you don't. Would you raise your hand and feel okay with the multiplication? Okay, I'm going to give you a couple problems on your own. They go very quickly, but I do want you to show your work on this. Don't just do them in your head. That's where the mistakes with those negatives happen.
I have a question. If you were to write that as a complex number, you would have plus 0i, right?
Yeah.
Okay.
Yep, and that's because right here, when you have negative 30i and positive 30i, how many i's do you end up with? 0 i's.
Oh my god, dude.
Okay, try these out. Let's see how you're doing. So we know we're multiplying. Wherever we get an I times an I, we're getting I squared, but then we know we can't leave this with an I squared. The I squared becomes -1. Distribute where you have to. Remember, this is different than adding and subtracting complex numbers. So on your test, I'm going to give you adding and subtracting and multiplying and dividing complex numbers. None of the math is too difficult. You just have to know what to do, what you can do, and what you can't. All right, we're about to get going. About to get going up here. Well, let's look at the first example. We've got -4i times 5i. The first thing we're going to do, instead of doing this in our head, we're going to write out exactly what we have when we multiply. So -4i times 5i, I know I can multiply those numbers together, and since I'm multiplying, I can also multiply the i's together and get an I squared. That's because multiplication is associative. I can reassociate terms. I know that we do the 4 times the 5, that's -20. I do the I times the I, and I get I squared. Did you get that far?
Yes.
Did you leave it?
No.
Did you leave it?
No.
Oh, I hope not. Are you ever going to leave an I squared?
No.
Never. You do have -20, but the I squared actually means -1. It's the square root of -1 times itself, or the square root of -1 squared. We know any square of a square root, gone. We get -1 out of that. That gives us +20. Yes, no?
Yes.
All right. Next up, we're certainly going to have to distribute. This is different than if I would have had like a plus in the middle of that or a minus in the middle of that. There, that'd be a different story. I wouldn't be foiling that. I would just be distributing the negative to the last two terms and then combining like parts. So you need to see the difference between addition, subtraction, and multiplication. They're all going to have parentheses around them. They're all going to have parentheses. But you need to know if there's a sign in the middle of it, addition, subtraction, that means you're not distributing. That means you're just either changing signs and combining like parts or dropping parentheses and combining like parts. With the multiplication, then yes, of course we need to FOIL this because I'm taking these two terms times these two terms. If I do that, it'll give me 12 minus 2i plus 18i and finally minus 3i, and I'm not going to forget that I squared because I had the I times I. Raise your hand if you got exactly that on your paper. Good deal. We'll change any I squareds that we might have. Here I can't change these things. I'm not going to even touch them yet, really. But I am going to change the I squared into a -1. That's our definition. We need to stick with that. So really what we have is 12 minus 2i plus 18i and then plus 3. Do you see where the plus 3 is coming from?
Mm-hmm.
We'll combine our like parts. Real parts come first. That gives us 15 plus 16i. Again, we don't make an I squared when we're combining like parts there. Only when you're multiplying I times I. That's as far as we can go, you're done. That's it. Now our last one, just want to make sure that you see this one more time. Of course, this really means 3 minus I times 3 minus I. Ladies and gentlemen, are these two things conjugates?
No.
Is the middle terms, are the middle terms going to cross out?
No.
Now we have the same sign. The conjugates, those had different signs. That's where those middle terms were being eliminated. So when we do distribute this, very similar to the last problem, we get 9 minus 3i, but a minus 3i again. That's why we're not going to cross those middle terms out. It's because we have the same sign. And finally, plus I squared. So far, so good? Well, we know we definitely have to change any I squareds that we see. So what this does, how much is that?
-1.
Yeah. So really what that means, I know I'm writing lots of steps, but that's kind of one of the keys here. The math isn't hard, you just have lots of negatives. Because of those I squareds, that means -1. What that does is really, instead of plus -1, really just gives us -1. Plus -1 is just minus, it's like you're subtracting. We'll combine our like parts here, we'll get 8. We'll get a minus 6i. Real part is 8, imaginary part negative 6i. It's certainly a complex number. It's as far as we can go. Raise your hand if you feel okay with our multiplication so far. Good deal. Now, we are going to talk about division. Here's how division is going to look for you. You're not really going to normally get a division sign like that. Instead, your division is going to look like that. Does it still mean division when I have a fraction? Oh yeah.
Eliminating the denominator like we did last time.
So we do have some division up here. We've got two complex numbers. First one, of course, is the 3 plus I. Second one, 2 minus 3i. Now, I want you to think of something. You've actually already done a problem like this before in this class. You actually already have. Why? How much is I?
Square root negative 1.
Square root? It's a square root?
Yep.
It's a square root. You believe me, it's a square root, right?
Yes.
It's not negative 1, it's a square root. So have you already done something where you had a root over a root?
Yep. The conjugate problem.
You've already done that. In fact, in order to divide these problems, it's very, very similar. In fact, it's so similar, it's exactly the same thing as rationalizing. Do you remember rationalizing in 10.5?
Yes.
You multiplied by the...
Conjugate.
One person does it?
Or we
We
said
were
Multiplied
all
by, I'm all like
talking.
anticipating. You multiply by the
Yeah.
silence. You multiply by the
conjugate.
conjugate, yeah, the conjugate. We multiply by the conjugate because we know that from our last example of multiplication over here, that those conjugates are going to eliminate the middle term and in fact eliminate all roots that we have. And we do have a couple roots. We have one here, that's not going to go away. But this one is. So to divide, we're going to multiply by the conjugate of the denominator. Well, let's give it a try. Let's see what happens. So first thing I know I'm going to do is multiply just like we rationalized with our roots. We still have some roots. They're only in I form, which is great for us. They're even easier to work with. It's kind of nice. Now the conjugate of, do we want to get rid of the I on the numerator or the denominator? What do you think?
Denominator.
So that's what you're going to rationalize. If I'm dividing, I want to get rid of this part. I want to make it so that I have one complex number at the very end of this. So when we do it, we go, oh, okay. Well, I need to find the conjugate, not of this one, but of this one. That's where I'm trying to eliminate the I. So what is the conjugate of 2 minus 3i, please?
Plus 3i.
Am I going to have anything up here?
The same thing.
Exactly the same?
Yep.
I'm not going to change this side again, am I? Otherwise, that wouldn't be 1. And what you're doing here is you're multiplying by 1 in a special way. If you multiply by 1, it doesn't change the value of your complex number. It doesn't change its value. It's just making it look different. What are you going to do now?
Distribute.
Oh, hey, that's why we cover multiplication before division, right? So we know how to distribute things.
Just multiply all of them.
I was confusing the distribute.
So when we distribute, we're going to have problems just like this all over the place. We got one on the top, we got one on the bottom. Now the one on the bottom here, the one on our denominator, what's going to happen to your middle terms?
And they're gonna go away.
Yeah, they're conjugates. That's what I just showed you over here on the previous example. So when we distribute, well, we're going to kind of do this quickly since we should have the hang of it at this point. We're going to get 6 plus 9i plus 2i plus 3i squared. We're just distributing. We're foiling that out. On the denominator, we're going to get 4 plus 6i minus 6i minus 9i squared. I know I went quick on the distribution, but that's something we should be able to handle right there. Are you still with me?
Yes.
Okay. Now's the part to take your time. I know you know how to distribute. Now's the part where you got to really think about the I squared, think about what's happening to those signs, and get them right. It'd be a shame if you guys knew how to do this and got this far and then messed the I's up and got different signs, or forgot about the I squared and got different signs. So we're going to do 6 plus 9i plus 2i plus 3. What's the I squared again?
Negative 1.
We're going to have 4 plus 6i minus 6i. If you want to eliminate these right now, that's fine with me. I'm just showing them so that you see every bit of work. minus 9 times, the I squared is -1. Again, go slowly, think through it. The toughest part about this is the negatives, that's it. Hey, you still right so far?
Mhm.
All right. What's this mean?
-3.
6i minus 6i. Those are the same term with a different sign. That's going to eliminate. This is going to be, is it going to be -9 or +9? Can you raise your hand if you can follow me down that far? Are you sure? Guys over here, yes? Right side? Okay. Let's combine what we can. If I combine these numbers, what's my real part going to be, please?
3.
What's my imaginary part?
11i.
Over?
13.
Good. You still with me, guys?
Yep.
Now, we're not quite done. No, we're not quite done. I know you're all excited, like, oh, yes, this is awesome. Just get the butt off of complex numbers. But there's one more thing that we need to do. It's not hard. Okay, it's not hard. You have no more real math to do. What you need to understand is that this really is not a complex number yet in the proper form. This is a complex number over a real number. Do you see it? You're just going to split this up and make a legitimate complex number out of it. How you have a legitimate complex number is a real part plus or minus an imaginary part. This is the only extra thing you need to do. You're going to take this and you're going to write this as this fraction plus this fraction. Remember, you can separate a fraction by using the same denominator in 2 spots. So here you get 3 over 13 plus 11 over 13 I. That's the complex number. You can always split a fraction up like that, where you use the numerator, this first term of the numerator over the denominator. Plus or minus, plus or minus. The second term of the numerator over the same denominator. Notice how they still have a common denominator, don't they? You could put those two things together. That's a complex number. What's the real part here, folks?
3 over
3
13.
over 13.
Good. What's the imaginary part? 11 13ths I, 11 over 13i. Now notice that you could reduce some of these fractions, if possible. Here you can't, because we have all prime numbers. But if they weren't prime numbers, you could reduce those fractions as well. So far, so good? You having fun? Do you like this section?
Yes.
I do. This is one of my favorite sections. Is it easier than you thought it'd be to deal with complex numbers?
Yes.
If not, then fine then, whatever. All right? How about 6 over 5i? How about 6 over 5i? Now, we know in order to divide things, in order to divide complex numbers,
Multiply it by 5. Sorry.
well, we're supposed to find the conjugate somehow, right? Here we have a real number, or a complex number with a 0i on the numerator, and we have a complex number, or imaginary number, 0 plus 5i on the denominator. Can you think of what the conjugate will be for this thing?
-5.
Why negative 5i?
It's the opposite.
0 plus 5.
Ah, so this really is like 0 plus 5i. You follow? Then our conjugate is supposed to be 0 minus 5i over 0 minus 5i. So basically, these zeros aren't doing anything. You just need to know if you're dividing by just an imaginary number, which we are here. The conjugate is just the opposite of that. It's 0 minus. So we're going to have the negative 5i over negative 5i. Ladies and gentlemen, are you all right with that one? Okay, let's see what happens. Are you sure? You're right? See what happens here. On the numerator, how much am I going to get?
-39.
On the denominator, how much am I going to get? Negative 25i squared?
Mhm.
Are we going to leave it I squared?
No.
Definitely not. No, no, no. I squared is how much? So we get negative 30i over negative 25 times, how much is that going to give us when we have negative 25? So I'll get negative 30i over 25. Can you simplify the fraction?
No.
Why not?
The I.
Well, yeah.
Should have write 0 1. Does it split it up? Like, I don't know, that's possible.
Sure you can. Why? These are just numbers being multiplied together. This is a square root being multiplied by 30, right? Square root of negative 1. You can simplify
So what
those.
if we write it like that? Are you gonna tell us we're wrong?
Yes.
Oh.
Well, you know, you're not wrong. You're absolutely right. You're just not done.
Oh.
It's like saying, am I wrong here? No, you're absolutely right.
This is.
Are you done with the problem? No, the answer is this. Right there.
You had it right.
You have it perfect. You're doing great. Just finish. Right, so here, you do need to simplify. That's going to be negative 6/5 I.
Oh. Yeah. I get it now.
You're done. Congratulations. Here's your prize. You get a smiley face from your teacher. Those are really the only two examples I can give you. Do you feel okay with them? Raise your hand if you do. If you don't raise your hand, I'm assuming that you don't. Oh, you do. Okay, okay, we got it. Try 2 on your own. We'll talk about one more thing, the powers of I, and then move on. Question?
Before you raise that.
What now?
On the bottom one, how it says like 3 over 13 plus 11 over
Yeah.
13. Is there any way that we could still like simplify that and then make it like where it's 8 over 13? Would it be wrong?
What now?
Or, I mean, I'm sorry, 13 over 39. Making it I.
Like
know
if
what I mean?
you add those?
No, yeah, right there.
Right here?
Mm-hmm.
Do what now?
If we're to add them, it'd be like 14 over 39.
No, okay, I see what you're saying. No, this is, remember that this is a number, and this is a number attached to I. It is really similar to having something like this. Can you add those? No. This has the I with it. Now I know I'm writing the I after the fraction, but notice it is still multiplied. This, the only reason why we're allowed to do this is because this is the same as this. True? Which is the same as, that's equal to I. That's why we're able to do that. This fraction is still this fraction. Okay, you're not allowed to add those together. That's why I can do the I at the back end of that. Same reason. Oh, did that answer your question?
Yeah.
So, because it's gone now. Okay, try 2 on your own, and then we'll talk about powers of I briefly and be done for our day. Do that one for me. And this one. So to divide those complex numbers, we multiply both the numerator and the denominator by the conjugate of the denominator. The reason why this works again is because that I really is a square root. It's a square root of -1, and we knew that the whole conjugate idea is going to eliminate those square roots on the denominator of our fraction. That's why it works. It's eliminating those i's because they're square roots. We just can't lose the fact that we're going to have some I squareds. We can't lose the fact that those things are -1, and that's going to change some of the signs inside of our problem. Hey, what's the conjugate we should be working with up here?
3 minus 1, I, 3 minus I.
Yeah, and don't let it change into a 1, right? That would be a bad thing. Hopefully you multiply by 3 minus I over 3 minus I. And then you're going to Did you get that on your numerator?
Yep.
12 minus 4I minus 3I plus I squared? You get the I squared? You get the 9 minus 3I plus 3I minus I squared? Hey, do these I squares simplify? Can you cross those out?
No, because they're combined.
Yeah, you get some subtraction in there and some addition. You can't do that. Next thing we're going to do is change any I squareds we have into negative ones. So we'll have the 12 minus 4I minus 3I, and then this is going to be plus negative 1. I squared is negative 1. I've written everything the same except the I squared. I have 9 minus 3I plus 3I and minus negative 1. So far so good.
Yep.
Did you guys all make it down that far? Okay. I'm going to change the signs here. That's what this is doing for us, really. We have 12 minus 4I minus 3I minus 1, and 9 minus 3I plus 3I plus 1. Do you see where the minus 1 and the plus 1 are coming from?
Yep.
We have plus and negative, that's minus. Minus and negative, that's plus. Then we'll combine what we can. We should get a complex number out of this. 12 minus 1, we've got 11. Negative 4I, negative 3I, minus 7I. 9 plus 1 gives us 10. Minus 3I plus 3I, that's what we wanted to have happen. Those i's are gone. We get this number. How many we got that far? Did you take it one step further?
Yep.
Yes.
Good. Our answer here is 11 tenths minus 7 tenths I. Split it up, make sure the I is on the back end of your fraction, and you're done. The last problem, of course we still need to multiply by a conjugate, but in our case the conjugate is simply negative 3I, and we do that on both the top and the bottom. We get negative 6I over negative 9I squared. We get negative 6I over negative 9 times negative 1. That's going to give us negative 6I over positive 9, and if we simplify that, we get negative 2/3 I. Would you raise your hand feel okay with multiplying and dividing these complex numbers? Now the last thing we're going to talk about in the last minute that we have, we're going to talk about powers of I. I want you to notice something. Of course, I to the first power is I. How much is I to the second power? Okay, I'm glad one person knows that. How much is I to the third power? And I to the fourth power? And I to the fifth power? Here's what we're going to look at. Check it out. I to the third power, do you believe me, I can write that as I squared times I.
Yep.
How much is I squared? This is really negative 1 times I. Negative 1 times I is negative I. You follow?
Yeah.
Check out I to the fourth. I to the fourth is I squared times I squared. Is it not? How much is I squared, folks? No, I squared's not I. I squared's negative 1. This is negative 1 times negative. How much is negative 1 times negative 1? Weird. I is I. I squared is negative 1. I to the cubed is negative I. I to the fourth is 1. How much is I to the fifth? I want you to check this out, okay? This is I to the fourth times I. Do you follow that? I to the fourth was 1.
Negative 1.
I is I. This is I. 1 times I is I. What just happened?
I have no idea.
What just happened?
Went around in a circle, you keep doing it back.
It's cyclical. It's going to go back. This is a little bit of number theory I'm teaching right here. Guess how much I to the sixth is going to be?
I to the fifth
No, negative 1.
times I.
How much is I to the seventh? How much is I to the eighth? How much is I to the 9th? 10, 11, 12, 13, 14, 15, 16, 17, 18. This is what you're going to do with your i's. And if you want to figure out how much I to the, just listen. If you want to figure out how much I to the 50th power is, you want to do this 50 times? No. Divide 50 by 4 for me right now. And find the remainder. Do it. Did you get 2? This remainder says I to the 50th is equal to I squared. The remainder tells you where you're at. So you divide your power by 4, because you have 4 in your cycle. The remainder says I'm equal to I to that power. So you just look back at your table. I know I squared is -1. Oops. Therefore, I to the 50th is equal to -1. Take your power, divide by 4, find the remainder. Hey, by the way, if the remainder is 0, I to the 12th, divide that by 4. It goes in 3 times, you get a remainder of 0, true?
Yeah.
How much is I to the 0 power? How much is anything to the 0 power?
0.
No, it's 1.
Oh. Trick question.
No, it's not a trick question. Anything to 0 power is 1, no matter what. Divide the power by 4, take your remainder, it's I to that power. There's only 4 choices. You have 1 through 4 or 0. It's 5 choices then. Did this make sense to you?
The last part, yeah.
Okay, check it out again on the video if you're a little bit lost. Also with those negatives, make sure you put 1 over that negative power as a positive. Remember, you can do that.